phase constraint, show phase constraint. Maybe I want to solid to shell conversion. Maybe I want to fill up surrounding space. So we have a lot of tools here to use. Maybe we want to blend, maybe to align, okay? And we have also the curves. I create the 3D shape and I can create the 2D shape. Maybe I want to create the 2D shape as polygon, line, circle, ellipse, arc, rectangular spline, 3D polygon, 3D spline, analytical curve. Maybe I want to give it as equation cosine of t, sine of t, and here z tangent of t. Give t from 0 to 1 or pi over 2. Press preview. Let me press space. Okay, let me press out of the domain the tangent x, no problem. 2 times t. Reset view. Okay. So if I want to press analytics, this is the shape I created. Okay, it's any shape, okay? But I told you that we can create an analytical shape. Okay, we can create an analytical curve. We can blend this curve. We can chamfer this curve. We can trim curves. We can delete the segments, trace curve and hill curves. Okay, we can do a lot of things here. And also, maybe I want to create a rectangle. Let me go but by press space and let me create a curve which is rectangular. Okay, let me create it here. So I create a rectangular and press it as a rectangular one. Okay, then if I want, I can extrude this. I can press the extrude face, or I can here the extrude curves. Okay, so maybe if I have 2D face, I can extrude it. Or maybe if I have to rotate the face, or here to extrude the curves. Okay, because here I create a curve, so I can extrude here. You see, when I go with the mouse, it's lighted. Okay, press it 2 times. You can give it a thickness. Let me press it as a T thickness. We can choose a twist angle or a tapered angle, and you can choose the material and the name. Let me press OK. We have now this one, which is solid 3. We create new shape. You can go to this shape to see the history tree. It's kind of curves. It's rectangular curve. Okay. Then we extrude the curve to have a 3D model. Okay, guys. So I can create any 2D shape or analytical. Maybe I have an equation and I want to create analytical curves. Then I go to make it as a 3D one. Okay. That's a very amazing task or very amazing tricks in CST software. Okay. Really, it's very amazing to do it like that. Anyway, let me continue. We have here blend to trace from curve, to conform strips from curve. We have this also, and we have these tools. Bond wire, we create a spline or JEDEC bond wire. We use this in different applications, but not here. Okay, so no problem about it. We can pick a point. As I told you before, I can pick a face, pick face chan, pick similar faces, pick edges. Maybe I want to press it. I can choose this edge. Okay. And to clear it, you can press clear. Maybe if I want to press F, I can pick a face. So I mentioned this whole face. Clear the picks. You see here, F is pick face. Maybe I want to edge, pick edge chain, pick edge from coordinates. We have a lot. Okay, we can start by learning them when we go through applications. So when I go with the application, I will use them. We can pick a, let me press here the arrow. We can pick edge center, pick end point, pick face center, pick point on circle, pick circle center. Okay, for example, I can pick the edge center here I press this edge, and here we have a circle. And the specific one, I want to align my WCS, the coordinate system, to this point. I press it. You see, the coordinate, the 0, 0, 0 coordinate will be here. Okay, so I can start from here. Or another one, I can press local WCS to go through to 0. Okay, the first one. Or maybe I will pick the face, press F and double click on it. We pick the face and we press align WCS, and we align our coordinate to the face. Okay, as you see in the top of the face, my coordinate. Let me edit properties, maybe to this shape. I can edit it, close, history list. I can see what I did from the beginning till now. Okay, and we can change this one, update or steps, or run to, or edit the steps and see. Don't worry about this, is for the cutting. Okay, so when you choose this, so the cutting will be different. Okay, no worry, this is 0 is perfect. So I can go with the cutting depending on the position I want, or X, and I can't through Y. So you see, we can do a lot of things with this. Anyway, after finishing with the modeling, as you see, we can go to simulation. In simulation, we have, as you see, simulations. All the parameters or the properties depending on the simulation. We have frequency. See, I put the frequency 2 to 3, I can change it. But as I told you before, I prefer to put it as the first time, and we can press help to see what this means. We have the background, I can change the background also, and the boundaries. Maybe I want to change the boundaries when I work, for example, in metamaterial. I want to change the boundaries to electrical, magnetic, open, add space, periodic. So unit cell, depending on the applications, I can change the boundaries. Okay, let me choose this. In simulation, we have a waveguide port, and maybe I want to add a waveguide port. The best way to add a waveguide port is by choose the face. For example, here, let me pick the face, this one. And when I press waveguide port after choosing this face, look, directly my waveguide port will be there. Okay, so I can add it like this. That's a great way. When we have a coax, we add it like that. Or we have a rectangular antenna or rectangular waveguide antenna, we add it like this for the waveguide port. We have discrete port as a discrete port or discrete port to wire face. So we have here, we can pick 2 points, like for example these points and these points. Okay, or we can choose 2 conductors, and let me create this. Sorry, let me create of the edge. So maybe I port between these 2. Maybe I want to change the voltage or current, or put it as S parameter and change the impedance of it. Okay, so depending on me, what I want, I can create. Okay, guys, we have plane wave, we have lumped element. Maybe I want to add a capacitor, maybe I want to add an RLC serial, RLC parallel, diode, spice circuit, or touchstone. So depending on me, what I want, I can create. Maybe I want to keep L and C 0 and add only a resistor with 100 ohm and to a specific position, or I press the points between. So maybe I want to add it here. This is work for what we say reconfigurable antenna. When we add circuits to the antenna, okay, we can do it like here and press element 1, or I can rename it to resistor 1 or anything else. Okay, here we add the lumped element, lumped element to wire, multi-pin lumped element, sub element, etc. For the signal, we have a new excitation signal. I can add a new excitation signal or keep the signal as it is. Okay, we have the field import and field source. In field monitor, we request the result we want. I request at the first time the far field at 2.5. Maybe I want E field, H field, field source, power loss, magnetic. Maybe here we want to power loss density to calculate the SAR. Okay. So some parameters may be needed, some parameters may be not. Maybe I want to see only all the parameters, so I can request all the parameters. What I need to do is choose the frequency and press apply, and it will directly appear here in field monitors folders. Okay, that's great. So we learn a lot of things. I hope you try by yourself all these things. Okay, I hope that, guys. Anyway, after field monitor we have voltage monitor. So we can see the voltage monitor, current monitor, field probe. Maybe you add a field probe and you want to see the calculation. I don't use all of this, but depending on your application. So you use it depending on your application. Maybe you press setup solver. You see here, now I can see the properties in it. Maybe you want to start all support at the same time. Maybe I want only port 1 to work in mode 1. Maybe I want port 2 to work. Maybe I want to press selection, and the excitation maybe depends what I want. Okay, maybe I want to change the amplitude, maybe the phase. So maybe I want to use sequential, maybe simultaneous. So depending on me what I want, it will work. Okay, let me choose all ports. Maybe I want to choose one or all mode. The accuracy, usually it's 40. Maybe you want to change it to decrease the time of simulation to -20, and maybe you want to increase it to -80 to have a better accuracy. Okay, but usually it's 40. Hexahedral or hexahedral TLM, depending on the mesh type you want to run. Homogeneous port, you press it to see the result in a correct way or more precision way. Calculate the port mode only. So you have a lot. Maybe you want to normalize to 50 ohm, maybe not. So all this will change depending on your application. Okay, the optimizer you want to use, the power sweep element. Here we create a parameter. So maybe I want to change the parameter from 20 to 120. So depending on me what I want, and press apply to start the simulation depending on this. Okay, let me press close, start the simulation. Maybe I want to use the acceleration. I want to CPU, change the settings to have more results in less time. So we have different things to change as parameter. Maybe I want to change this. I want to calculate all of this, or maybe not all. Maybe symmetric, maybe not. So adaptive mesh refinement, use sensitivity analysis. So you have a lot of properties you can change. Okay, and you will see this all parameter. But usually we didn't work on this. Usually we put the accuracy and start the simulation. Maybe you change the port. Maybe you want to use optimizer, but not all of this at all the time. Maybe you need it. So depending on the application, as I told before. And when the solver changes, some parameters will change also. Okay. Here you have mesh, global, the intersection check. It should check the intersection between mechanics, for example, check. If you have any intersection, you have intersection between elements. Okay, let me press OK. And you have another intersection, let me press OK. So you have intersections between elements. Yeah, because I create a random element, okay, or random components. Okay, guys. So let me go to post-processing. Here we can import or export the result or as ASCII code to go through TXT file for maybe to read it in MATLAB for S11 or any type of results you have. Maybe you wanted it as an Excel shape or Excel sheet, so you can do it when you read the TXT file or TXT file from Excel. Maybe you want the S parameter calculation, I diagram. You have the I diagram. You have a time signal here. Sorry, I press I diagram, waiting for it. So we have a lot of tools in the post processing. Maybe you want to calculate the SAR after the simulation. Okay, so I can go and press SAR to calculate it. So here you have yield analysis, spice extraction, transmission line and vector fitting. You have loss and Q, result template. Maybe you want to request some result as a 2D for field antenna properties, filter, generate what you need to have. Okay, maybe I want the loss from E, so I requested. Okay, here we didn't have any simulation for that. Anyway, I will create this. You see, I will create this, and after I simulate, I will have this result. So from this, it's very important because not all the result will be here, because you should request the result you need, okay? You should request the result you need. Maybe I want S parameter, and from it I want S parameter is time getting, Y parameter, Z parameter, extract permittivity and permeability from S parameter. So I can choose anything I want, and it will calculate directly. You see here? As you know, for extracting material properties as permeability and permittivity, you need S11 and S21 in the equation. So they request it and give it. You can press help to read all these tools, okay? Anyway. And here also we have the view. This is not very important, but we use it a lot because you can, let me press space, you can remove the working plane or edit. You can wire the frame. You can see this as a wires. Let me see it. You can remove the axis or edit, bounding box or edit. You can show what you want to show. Maybe I don't want to see this. Let me hide it so I cannot see it now, okay? Or I will show it, so I can show this. We can hide alls and show alls, okay? We can export the image. Maybe I want to export this image to a specific folder like desktop 3d.png. So I see this image in 3D, but before we export it, let me do this. We sure remove everything to code the image, because we want to add it in a paper maybe or in our thesis. So it's better to remove everything and code the image. From my opinion, you can do what you want, okay? And here we have the dimensions. Maybe I will change the dimensions, and you see it's the dimensions here. I have CST 2020, so maybe if you have an old version, this properties not exist, okay? Or some tools not exist, but in 2020, all of this exists. Maybe 2090 also exists, okay? We have rotate, we have the pan to change it, we have the reset view, we have the stage view. In stage view, maybe I change the background, so maybe your background not like me, white color, okay? Maybe you have this one. So it's different, okay? So first color for me, it's white. I choose always this color because it's more easier for me as a paper, okay? When I want to create a paper or add this image to any document I write, it's better to have a white background, okay? So here we can work with the stage. Let me close the stage. We have axis scaling, the cutting, as I told you before, and the window I want to see, message navigation parameter. As you see here, I can remove one of them or all of them or edit, okay? And here we can change the style of this to below each other or across each other, etc. Okay? So here it's the properties we have in this antenna design. So let me go to modeling or save my project as webinar 1. Let me save it in a desktop. Let me call it webinar 1. WB1. Let me save it. So the name will be WB1. Okay. And let me go to documentation to see what we forget to describe. We forget the loft operation. We will start by it. Okay, the loft operation is the way to create a horn antenna. It's the same way as a rectangular waveguide antenna. It's the same. Or cone antenna. We will create it as a loft operation. We have bending to maybe create a helix antenna. I told you about it. The blend to change the edge of it. First, you select the edge, then you press blend or chamfer edge to change it. I will do it also. And the shell operation to make it not have any thickness inside it. So let me do it and go on. Let me go to CST and let us delete everything we have. Yes. Okay, let me delete also the ports I have. That's great, and also the curves. Okay, that's great. So here, let us start. Okay, we have a lumped element, so let me also delete it. Okay, that's great. Okay, let us start. I will start by create a box which has a -10 to 10, -10 to 10 with thickness 1, and the material will be PEC, perfect electric conductor, preview. Okay, let me go inside. Let me change the thickness to be 10 also, because it's more easier for us to see. 10. As I told you before, I can put it as a parameters to change it from here directly, or I can put it as a numbers. It depends on me, but I prefer to create it as a parameters. Okay, guys? Anyway, I have a component. Let me zoom in. Okay. Okay. Let me choose the edge. I pick the edge using E letter, or I can go here and instead of pick face, E, or press pick edge. Okay, I press this edge, and here I can go to blend. And blend, we have blend edge or chamfer edge. I can press blend. You will see the difference. The radius will be 0.1. Preview. Let us wait. Let me put it as 2. Preview. Okay, it will be more see from me. Okay, you see the difference? This is the blend. Let me press E again and choose this. And now I will chamfer it with 2. Preview. Okay, it will be. You see the difference? This is the chamfer. You cut from it as a rectangle, as you see. And this is the bending way. Okay, as a bend, it will be a curve, but here it's chamfer. So I cut it from it, okay? So as I press E, you can see it also from here. If you look to it, this is the blend, it's a curve. As the chamfer will be as a rectangle, as a shape. I will cut it as a rectangle, okay? This is chamfer edge. Let me clear the pick. You see, this is the way. Anyway, we have, let me delete it or keep it. We have this, okay, guys? I will create another break. Maybe my break will be a rectangle, maybe a circular or cylinder, it depends on me. And I want to put it as -10, sorry, -20 to 20, or -50 to 50, -50 to 50, or no, let me say it's from 50 to 100. I will tell you because I want to change the position from 0 to here, because I want to use new technique, okay? And for Y, -50 to 50, it's not a big problem. For Z will be 10. Let me press preview. Okay, instead of 10, let me take it to 50. Preview. Okay, that's great. But instead of 50, let me add 100, and this will be 120. Preview. Okay, that's great. So we have another object at this. We want to use loft. Why we want to use loft? Maybe I want to connect these two, okay, to create a new antenna, or to create a cone or rectangular waveguide, or any type of waveguide antenna, okay? We want to connect them, or any shape. Firstly, we will go to pick face, or press F or pick face. You pick here. Then you will go to this way and press F also to pick it. Okay? We have these two faces because we want to connect it. But how we can connect it? We will go and use this one, the loft. Connect two picket face. Okay? Two picket faces. So, and this way we can connect it. How? We can press preview. In the preview, as you see in the preview, I can connect it. I can change it. Let me change it. You see? It changed. I can change. It will change. let me put it as 0.3 and press OK. You see, I connect these two faces and this way. So we have different way to connect it depending on the left factor. Okay, I can put it as a variable and change it, or put it like that. So depending on me. Okay, guys, let me press F here, and let me also press F here. Why I do it? Let me now try to use the shape to, or maybe modify the shape, maybe, I don't know what I should do, to make it whole. Okay, create a hole inside it. Okay, let me press reset view. Now I choose the faces. When you choose the faces, you can hold it. You can use the hole. Okay, let me first, if I have this 3, let me delete the 1 and 2 first. Okay, we have this. Let me first press F to press here, and let me press F to press here. Then I will go to Shape Tools. In the Shape Tools, Shell Solid, I can press it. Inside, the thickness will be 2, Preview. So everything inside it, it will be removed. Okay? Let me press 0.1, for example, Preview. Okay, the thickness is greater than it. Anyway, press OK. So here, if you look to it, nothing between, okay? Nothing inside it. I use shell, solid, or thickened shell. And the thickness will be 0.1. So the thickness here will be 0.1. Press P. Press P. It's 0.1 here, okay? Let me clear the pics and press reset view. So I can do it like that. Here I put arbitrary numbers, but you can do it in a better way, okay? Let me also press F and choose this. After choosing this, maybe I will create the waveguide port here. So I create the waveguide port, and now I have kind of waveguide antenna, okay? This is the waveguide port. This is a inside nothing, so the wave will go on. Okay? So we can do it in this way. Okay. We use the shell operation, the transform option, we learn it, the local modification, we talk about it, and that's it. Okay. Here they tell you about different type of solvers. We have different type, you know. The type of solver, we can choose it depending on the electrical size, the geometry problems, the material models, material parameter, resonant behavior of the model. Maybe here you can choose frequency, the architecture of the workstation, the size of the architecture. So different things depend on the type of simulation you have. Okay? And also the excitation signal, as you see before, I show you how to change the excitation signal. So maybe you have it, maybe you want to change it. And here you have the frequency domain to calculate each point for the frequency. As you see here in the documentation, you can see what's the transient, what's the frequency. It's for here for electrical medium and large size problems or broadband, arbitrary time signal. Frequency domain will be for narrowband, single frequency. So we can use the type of solver depending on your application. Okay? And here some tables to, for example, if you have weak resonance, okay, time solver is better. Strong resonance? No, not go with this, go with resonant fast for frequency. Okay? For AR filter, for S parameter calculation only, okay, time domain. But for general purpose, frequency. It's the middle between strong and weak resonance. Okay? So depending on the application, you will choose the type of solver to use. And depending on the size of the structure, you will change type of solver, because maybe you have an airplane. So an airplane, you have a big electrically large dimensions. So for it, you can use integral solver or integrated solver. Okay? So for that, we can choose the types depending on the shape we have, or the size we have, or the properties of the application we have. Okay? For here, we can finish our first webinar. It's really nice to meet you guys. Please don't forget to fill the documentation. We will upload in the comments section at the end of this webinar. So don't forget to do it, okay, to have your certification. And for the second webinar, we will start to learn how to design the antenna by the calculations and go on to request the result by a professional way for you. And also we will try to prepare workshops, so you have a short course about how to work with antenna and how to design antenna with different software like CST and HFSS. Okay guys, so thank you till now, and I hope this kind of webinars will take your attention. Okay, so thank you, and I hope I will meet you again in another work. Thank you guys.